Well, hello guys and welcome back to Mr. G Physics. This is Mr. G and today we're going to be solving a question for the grade 11 related to electromagnetism. This is question 8. It was question 8 done in June 2023 in the Northern Cape province. The question said the arrangement of the solenoid and magnet shown below is used to investigate Faraday's law of electromagnetic induction. And then you can see a solenoid and a magnet that are moving relative to each other. You can see the deflection in the middle. Question 8.1.1 states Faraday's law of electromagnetic induction. And here we have the magnitude of the induced EMF across the end of a conductor is directly proportional to the rate of change in magnetic flux. The EMF, guys, is equal to minus N multiplied by the change in magnetic flux divided by the change in time. This one we can see here that the EMF is directly proportional to the rate of change in magnetic flux. We come back here. This one here is the rate of change in magnetic flux. That is the rate in change in magnetic flux. The next question says there are two ways in which the deflection of the galvanometer can be increased. And guys, we go back to the formula. We can look here. Well, how can we increase the EMF? Well, if we increase the number of coils here is one way. One way is increasing the number of coils. The other one is using a stronger magnet. If you change the magnet for a stronger one, then the magnetic and the EMF induced will be bigger. So it can also be by using stronger magnet or move the magnet quickly. So move the magnet faster. Those are the three factors that can actually change the induced EMF. So guys, this one is question 8.1.1 and 8.1.2. Now we're going to question 8.2. Square coil with a side of 2 centimeters and 250 turns is placed perpendicularly in the uniform magnetic field of 0.5 Tesla. The coil is rotating through the angle of 45 degrees in 0.5 seconds. Calculate the induced EMF of the coil. For this one, we're going to write the data here. So what we have, the side of the solenoid, which is a square, I'm going to write length, is equal to 2 centimeters. Remember, you cannot work with centimeters. So you convert this one in 0.02 meters. The second is that there are 250 turns. This one is 250 turns perpendicular. Now this one is the angle is rotating, so the angle doesn't change uniformly or stay constant. Now the angle here could be tricky. When they say it's placed perpendicularly to the uniform magnetic field, that means that the angle is going to be equal to 0 degree, perpendicular to the magnetic fields, mean that it's 0 to the normal of the magnetic field. That angle could be tricky, guys. Now the magnetic field is constant, it does not change. Therefore the magnetic field is going to be equal to 0.5 Tesla. What else? The coil is rotating, so the final angle, you have initial angle, the final angle is going to be equal to 45 degrees, and the time we have here for this to happen is 0.1 second. This is the data, and it could be tricky. So let's go to write or calculate the EMF. Now the EMF is equal to minus N multiplied by the change in magnetic flux divided by the time. Now we don't have the change in magnetic flux, so let's look for the change in magnetic flux here. That one is final magnetic flux minus initial magnetic flux. This one is equal to magnetic flux is the product of B times area multiplied by the cosine of theta. All this is final, all right? Minus, this is B final, A stays constant, it won't change, but final theta, this is minus B initial, A cosine of initial theta. B is constant because it's a uniform magnetic field. So when you substitute here, you get 0.5 multiplied by the area of the square. Now how do you calculate the area of the square? That one is equal to B square, okay? Or for instance, you can say is base times height. but that one is the same because it's n squared. Okay, so this one is now here. So the area here will be, 0.02 square. Cosine of theta, the final one is 45 degrees, minus, and then it's 0.5. You can use common factor here, guys. It's a common factor here that can be done. This is mathematics multiplied by the area, which is 0.02 square multiplied by cosine of 0 degree. That was the initial angle. So this one will be 1,414 times 10 to the minus 4 minus 2 times 10 to the minus 4. We get that this one is minus 5,86 times 10 to the minus 5 Weber. Okay, now we substitute in there. So the EMF is equal to minus, the number of turns was 250 multiplied by minus 5,86 times 10 to the minus 5, and the time is 0,1. Well, when you finish this calculation, you will get that the answer is 0,15 volt. That is the final answer for this question, guys. I hope you understand. It's a good question to practice for the upcoming June examination for the grade 11s. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G